Hi everyone, I'm Toby Swan at tobytutors.com, and this is the first of my online GCSE physics course videos. What we're going to be doing in this session is I'm going to explain what the presentations are, how they're going to work, what you'll need, and then I'll go through a few of the key physics skills that you'll need when looking at further topics. I don't want to be spending too much time during those topics looking at these key skills. So I'll cover the majority of them now, and then we'll move on to the forces and energy will be the next videos. So what you'll need for this video and for the next videos, pretty much up to you. Some people might want to write stuff down, some people might want just to listen. I would suggest strongly that you do want to be as proactive as possible. So writing stuff down, writing down some notes possibly, going through the examples in particular, and then at the end of each topic, I will give you some questions to have a go at as well. I'll give you the answers. I'm not going to go through those in detail, but you can certainly get in contact with me if you need more details. I would recommend working in a quiet room, getting away from distractions, getting away from your phone if you possibly can. Easier said than done, but I would definitely try to do that. Do not disturb is one thing you can do, but even then, it's so tempting to press that button and have a look, see what's going on. So I would put it in another room, get rid of it. You will need a pen or a pencil, a ruler, calculator, protractor for some of these videos, but the majority probably not. But the calculator, ruler, and pencil, certainly. As we go through the videos, the format will pretty much be the same. We'll have green boxes where I have something that's really worth noting down. I will talk around the topics, but you don't want to be writing everything down. That's just going to take too long. Take it in, of course, but the stuff that you really need to know, I will put in these green boxes. So physics is the best subject. You can write that down straight away because that is important. Blue boxes will be the examples that I give. I will work through these examples in detail. So you might want to jot down some notes for that, or you might just want to listen and try and really understand what's going on. And then finally, the yellow boxes are the you-dos. That is time to check your understanding. That is over to you. You'll probably want to stop the video, look at the question, and really try and work out what the answer is. I will give you the answers to those, as I said. So the key skills in physics is what we're going to look at during the majority of this particular video. I'm not going to look at all the key skills, but I want to look at some main key skills that people lose marks on regularly and just that you want to get very, very good at, very familiar with. And the first of those is my bugbear, unit conversions, because people do not sit down and learn these in the way that I'm sure you would if you were asked to go and learn some vocab in French or vocab in Spanish or some dates in history. You have to learn those dates, you have to learn that vocab, but people for some reason put this off. The longer you put it off, the harder it's going to be. So you want to learn these prefixes as soon as possible. I would say there's at least 5 marks in the majority of the papers that you will do for physics, dependent on knowing these prefixes. They won't be given to you in the formula sheet. So if you are going from a prefixed unit to a standard unit, you are going to multiply it by this multiplier. If you have, I will look at some examples in a second, but if you have a prefixed number like a kilometer and you want to turn it into meters, then you are going to multiply it by the multiplier. Here is the multiplier. Okay, you need to know what these multipliers are for these prefixes. If you're going from the prefixed number to the standard number, then you're going to divide it by the multiplier. Okay, now you can usually work out if the number is going to be bigger or smaller, but you might not, and if that's the case, then you will need to learn these rules. But as you get used to it, as you do more practice, you should get better at that. So some examples, converting 16 kilometers into meters. Here we have a prefixed number. We have a prefixed quantity, a distance. We want to turn it into a non-prefixed, and the rule is that if we're turning it from prefix to a standard unit, then we are going to multiply it by the multiplier. So the multiplier in this case is 1,000 for kilo. So we're going to multiply 16 by 1,000 and we get 16,000 meters. Hopefully a fairly straightforward one. If we were going to go the other way, this time we've got 2.37 grams and we want to turn it into milligrams. So again, I need to find the prefix first. The prefix is milli, which is here. And I'm going to, this time, divide it by the multiplier. The multiplier being 1,000th, or 0.001, or times 10 to the minus 3. If I divide it by that, then I'm going to get this number, 2,370 milligrams. Yeah, as I said, hopefully it will make sense. You want to do a mental check as well. Always with any question, you want to just to check common sense. Does it make sense? So over to you. Have a go at these questions. And your answers. Some tricky ones at the end there. Reach out if any of those were difficult before we move on to the next part. So doing calculations, obviously, is a huge part of physics. A lot of people struggle with the maths, but there are only a few key skills you need to transfer over from your maths for GCSE physics, at least. Most of them are to do with rearranging equations. And most of the equations in physics, there are a few exceptions, but most of them involve just 3 terms. And if I was in a maths lesson and I asked you to rearrange a 3-term equation, I'm sure you would find it relatively straightforward. But put you in a physics lesson and suddenly people start to struggle. So it is useful to be able to rearrange it, but actually in order to maximize your chance of getting marks, it's much more important that you substitute the information first. And I will try and do that through examples throughout this whole course. Substitute and then rearrange. Of course, can't get away from this either. You must also convert the prefixes. We've just looked at prefixes. They need to be, for your equations to work, they will almost always need to be in standard units, not prefixed units. As I said, there are a few more slightly complicated equations. As we get to those, I'll spend a bit more time on them. But most of them are 3. I think I'm going to look at a few slightly more complicated ones in a second now as well. Don't forget the units also. They help you to remember the formula. As we come to topics, I'll explain how those units can be really useful in remembering the formulae, or hopefully not even needing the formulae, because the units kind of define what's going on. Okay, so here's an example. The resistor is connected in series with an ammeter and a voltmeter across it. Its voltage is found to be 3 volts, whilst its current is 15 milliamps. What is the resistance of the resistor? So first thing you're going to do is to write down the information you have. It might not be obvious what formula you need here. So let's write down what we've got. Well, we've got a voltage. So let's write down 3 volts. We've got a current. Let's write down 15 milliamps. And I can immediately see that that is milli, so I want to convert that into amps. I do my multiplying out, and I'm going to get 0.015 amps. What do they want us to find out? They want us to find out the resistance. So we've got our voltage here, we've got our current here, and we want our resistance. I'm going to put the question mark there. Put the question mark there, and hopefully we can see that the information we have and the information we want is going to relate to one of the formulae, which will be on your sheet, or you can remember, be familiar to you, we can use V equals IR. But we want to ultimately rearrange that because we want R. But before you do that, we're going to substitute. You're going to get a mark for substituting. So let's substitute the information. We get 3 volts equals 0.015 multiplied by R. And then hopefully we can see that R is 3 divided by 0.015. Get our calculator out. And the answer is 200 ohms. Okay, I've gone through that. I've written that down in this case because it's the first one. I'll show you the working now, printed out. Hopefully that will be equally clear. So there's your information. Substitute, rearrange, and there's your answer. Example number 2. A rocket has a mass of 700 kilograms and 3.2 megajoules of kinetic energy. How fast is it moving? So I'm not going to write this one down. I'm just going to show you the calculation. First of all, the process, looking for the prefixes. So we've got our kinetic energy is 3.2 megajoules. We immediately notice that megajoules and we convert it into joules. Our mass, which is given us in the question, is 700 kilograms. Point worth noting here is that kilograms, although it's prefixed, all the formulae that you get will want mass in kilograms, not grams. It's the only one that the standard unit has a prefix. So we're going to keep that as 700. Then we want to know V, so we need to think which formula we're going to use. Slightly more complicated one, but half mv squared. So again, we substitute it in that form. That's going to get us a mark. And then we can rearrange it. Rearrange it, and that should be our answer. Quite a tricky rearrangement, that. If you're not so confident in your maths, you might want to slow down, have a workout of what you can do to work out that V. But that should be your final answer. Don't forget your units, meters per second. Mental check, does it make sense? What are we talking about? We're talking about a rocket. So you'd expect it to go pretty fast. We're talking over 1,000 meters every second, over a kilometer every second. But it's a rocket, so yeah, I think that makes pretty much sense. Okay, some more examples for you. Have a go at these. Okay, going through the answers now. That's the formula you're going to use. These are all the formula you're going to use. Might have wanted those, so you might want to pause it again, actually. And here are the answers. Okay, the next skill, finding the gradient of a graph. Now in GCSE physics, very often the gradient of a graph, as well as the area under the graph, often represent physical quantities. Going through so very often finding the gradient of the graph is really useful in GCSE physics. It gives you represents a quantity that you might need to find out. But often people are not that great at finding the gradients. So for example, speed can be found by determining the gradient of a distance time graph. Acceleration can be found out by determining the gradient of a velocity time graph, or resistance from a voltage time graph. Lots of different examples. All you need to do is think back again to your maths. Its gradient is change in y-axis divided by the change in x-axis. So in these examples here, you've got some really simple examples. Your change in y over change in x, your increase in y over increase in x from this point to this point. The increase in y is 1, the increase in x is 1, so 1 over 1, gradient of 1. Second one here, we've got an increase in y of 2, an increase in x of 1, so it's 2 over 1, a gradient of 2. The final one, your increase in y over your increase in x from this point to this point is going to be 3 over 1, which is 3. So the final thing you want to really think about is that although I haven't given units on these particular examples, you'd also divide the units. So whatever the y value is, whatever the units of the y value is, you're going to divide that by whatever the x value units are. So we'll look at some examples now. If you look at this particular example, we've got 2 lines here. I'm going to just use exactly the same idea. Let's have a look at The red example, the red line here, or the brown, looks a bit brown to me. The red gradient here, we're going to take the change in y over the change in x. So here's our change in y. I'm going to take the whole line. Okay, I'm not just going to do a tiny little box here. I'm going to do the whole line. So my change in y is 10 meters. Notice I said meters, I've used the units. My change in x is 5 seconds. So I'm going to divide 10 by 5, which is 2, but I'm also going to divide meters by seconds, which is meters per second. So I've got a speed there, or a velocity, 2 meters per second. If I was going to do the green one, the green line now, same idea. My increase in y, or my change in y, is going to be from here up to here. Let's do it along that point. Going to use the whole triangle again, the whole graph. Here's my increase in x this time. So now I've got 5 divided by 10, but I've also got 5 meters divided by 10 seconds. So again, I get 0.5 meters per second. That gives you the units for speed. Really, really important. But what if we have a curved line here? Well, for more advanced questions, they might ask you to find the gradient at a particular point. To find, for example, the speed. This speed of this object is changing. But they might ask us to find the speed at a certain time. So in this case, maybe they're going to ask us at 6 seconds. What is the gradient at 6 seconds? And for this, a new skill, we need to be able to draw a tangent. I want to find out what the gradient is there, so I need to get my ruler out, and I try. It's not great. It's hard to do on a computer, but with a see-through ruler, I would recommend you get a clear ruler. It's easier to get an idea of what the gradient is. You can move your ruler around at that point, and you want it to be as close to what the actual gradient is there. You want it to be not leaving any gaps here and any gaps here if you can. You can see there's a big gap here, but on the actual point you want there to be no gaps. So I'm fairly confident that that is the gradient of my line at that point, close enough. And then I'm just going to work out the gradient of that straight line. So again, my change in y, roughly, I'm only going to do it roughly, but my change in y is 8 minus 0. My change in x a little bit more difficult because it's not starting at the origin. Let's say it goes from 12 to 2.5. And so my change in x is going to be 9.5. My change in y was 8. And now I can do my delta y over delta x, my change in y over change in x. This was my value for delta y. And I've got 8 divided by 9.5, which is 0.84. Units. Don't forget, I divided those units as well. So it's change in y divided by change in x. It's meters divided by seconds, so it's still meters per second. Okay, the next skill we're going to look at is actually describing these graphs. So very often they will ask you, they'll show you a graph and they'll ask you to describe a graph. It also, it's a relationship between two variables. Sometimes they'll give you experimental data and they'll ask you to describe how one thing varies with another thing. And there are some key rules here that people often forget. The first two, fairly straightforward. So it's a straight line. Okay, so either of these two top ones, the red one and the green one, they are both linear. They change whatever y is and whatever x is. Y is changing at the same rate as x is changing. That's what makes them have a straight line. But there's a particular case that they often ask about, which is when it goes as a straight line, like this green one, but it also goes through the origin. If it's a straight line and it goes through the origin, then it is called directly proportional. Don't just say it's linear. if it goes through the origin as well, it is directly proportional. So next we want to look at these curved lines. Okay, it's very easy for people to say that as x is increasing, y is increasing. But that would be the case for any of these lines that I'm drawing here. Okay, a straight line, a linear line. All of these, y is increasing with x. But we want a little bit more detail than that. If we look at this black line here, we can see that as x increases, y increases, but it's curving upwards. Curving upwards isn't a description of what's happening though. So what we want to say is as y increases, x increases, or as x increases, y increases. Y is increasing as x increases, but y is increasing as x increases at an increasing rate. Okay, it's getting steeper, so we say it's increasing, but it's increasing more and more and more. It's increasing at an increasing rate. If you think about that for the blue line now, think of in the similar terms, and you might say that, well, y is increasing as x increases, but it's getting less, so it's increasing at a decreasing rate. Okay, and these are very common descriptions, really easy to roll out. We can just say it flattens out, not a great description, but as y is increasing as x increases at a decreasing rate, and the gradient is decreasing. So these terms here, these phrases are key phrases that you can get in there, maximize your marks. So some examples here. Classic example of a filament lamp here, voltage and current. Have a go at that. As voltage increases, current increases, but at a decreasing rate. Here's another example. So for this one, we're looking at Hooke's law, spring most likely, and you can see it's similar, but it starts linear. It starts directly proportional, in fact, because it goes through the origin, and then it starts to curve off. So up until the limit of proportionality, the force and extension are directly proportional. Beyond the limit of proportionality, force continues to increase with increased extension, but at a decreasing rate. That's why it's curving off. I'm going to stop there. Hopefully you found that video useful. What you should know by now is how to use prefixes. You should be able to carry out simple calculations to maximize marks by substituting before you rearrange. You can calculate gradients of graphs, and you can describe some simple relationships between two variables on a graph as well. I look forward to seeing you for future videos. Bye-bye. So if you found the video useful, don't forget to check out other videos on this platform, or go to my Facebook page here, where I've got other free resources, or feel free to book a call at tobytutorsphysics.com as well. See you soon. Bye.